Good morning to all of you. Once again, I am here with you for the new session, and basically, a little bit interrupt was there for the few sessions. Definitely, we will cover that whatever the gaps are to be there. And here with the solid state physics in the unit number 2, that is the bondings in the solids. Again, we have seen few bondings basically responsible for the whatever be the bonding in the solids are to be there, and how the solids are going to be formed, in which we have seen in detail basically what is mean by to be the ionic bonding, and in which basically when the in the outermost shell of the any atom, the whatever be the electron that is called to be as an valence electron, that going to be transformed from one to another, and it is giving you a stability likewise as an nearly equals to the whatever be the inert gases weight, or that is to be configuration, electronic configuration is to be there, and it is so going to be similar in that case, and such type of the bonding which is to be there, which is nothing but to be your ionic bonding we can say. Secondly, we have seen what is mean by to be as an covalent bondings are to be there. It is basically what to be sharing of the electrons are to be there in between the Na and the Cl, how the sharing is to be there, and how the covalent bond, or basically H2O, the how oxygen is to be creating two covalent bonds with the hydrogen, and the whatever be the strength is going to be distributed in that case, and the two covalent bonds are to be there. Again, we have seen in the carbon, that is sp3 hybridization is to be there in that case, how the covalent bonds are to be there, but it is somehow giving you the covalent bonding in a strength distribution is to be there. Again, we have seen what to be as and your van der Waals bondings is to be there, and how it is going to be the partial sharing of the particularly your electrons, outermost shell electrons are to be there, and what the ions are going to be formed due to either the stability of the configuration is to be there, but still these bonds are weaker bonds are going to be formed. And now today we are looking for this hydrogen bonds are to be there. Definitely when the word hydrogen bonds are to be there, definitely hydrogen will be the one part as far as the hydrogen bonding is to be concerned. Now let's see what is there in this last bond, that is called to be as an hydrogen bond. Basically, when we are looking for the such type of the bonding or hydrogen bonds are to be there, it is when we are aware about that, as far as the H2O is the basically as in giving you the good example for the covalent bond, and in which the H, that is hydrogen, is to be there, two hydrogen molecules and one oxygen atom is to be there, when that it is going to be called to be as an H2O, that is your covalent bonds are in between them, when it is going to be formed, two covalent bonds are going to be formed. When the covalent bonds are going to be formed between basically H and oxygen is the one taken, another atom. But likewise, if you see the similarly fluorine and the chlorine is supposed to be taken in the similar way, in that case the shared pair get attached towards electronegative atoms. Now the what is called to be as an electronegative and how it is to be as an electropositive, we are aware about that the H is having only one electron, as compared to the oxygen it is having the six outermost shell valence electrons are to be there. And due to that, so that whatever the electron number is to be there in the outermost shell is maximum in this your oxygen, and due to that it is becomes to be as a more electronegative, and that is having the more attraction towards itself, and that is why the oxygen is to be nothing but to be, we can say, it is electronegative. As far as the hydrogen is going to be concerned, it is only having the one electron in the outermost shell, and when it is two hydrogen atoms are going to be covalent bonds going to be formed, in that case the more attraction or the more strength is towards the oxygen, and that's why it is to be as a more electronegativity, we can say that oxygen is to be there. But as the more electronegative we can say, or the electronegative is basically as in become your oxygen. Similarly, as far as comparing with this oxygen, hydrogen is having very less, that is one electron, and due to that the less amount of the electron that gives itself as an electropositiveness, and that is why again that one electron is also going to be covalent bonded with the oxygen, and due to that the it becomes to be as an electropositive we can say. And that's why H is nothing but to be here in this case the electropositive we can say, and oxygen is nothing but to be say it is electronegative. In the similar way, whatever be the fluorine chlorine is to be there, then when it is sharing covalent bond is going to be attached with each other with as an H hydrogen atom, such molecules it says to be polarized. And in this case when the such a bonding is going to be formed, that not only one single H2O, there are number of H2O molecules are going to be there, and the such type of the bonds covalent bondings are to be there. But now oxygen is more electronegative and hydrogen is electropositive, either in the one particular segment or the basically having to be as an electronegative, it attracts another one H atom from the another molecules, and that is how it is going to be the call to be as an when such type of the particularly H molecule is going to be as an polarized, behaves like a permanent dipole. Such type of the interaction in between these dipoles is, and the forms the dipole is to be there, and such type of the dipoles interaction is nothing but to be the interaction between the dipoles, and where H atom is the part of that, and that gives you nothing but to be your hydrogen bonds are to be there. If H atoms are participating in the bonding, and then it is to be as an hydrogen bonding we can say. But if H, that is hydrogen, is not there for the forming such type of the bond, it is called as a dipole bonds. And here it is the word where it is to be as an when the H is not the another molecule, then in that case it is called to be as a your dipole bonds are to be there. Now if you will see this particular diagram, then it will give you clear picture about how it is going to be formed. If you look at in this case, here is the this is what the one H2O, this is another H2O, and this is another H2O. Now look at whenever this covalent bond in between the H2O, that is the two H atoms, which gives you the partial sharing is to be there, sharing is to be sorry there in between the oxygen and the hydrogen, two hydrogen atoms are to be there, and due to that the covalent bonds, two covalent bonds are going to be formed, and they are strongly bonded with each other, that is to be there. But here in this case what happens, either as I already told you, this H becomes electropositive, this is to be there, and this O becomes to be as an electronegative. Now this is for the one complete case where it is to be as an one H2O is to be there, but there is one another H2O which is to be also similar case is to be there. This is second one, and here it is also to be as an another one H2O is to be there, this is to be third segment. Now what is going to be there, oxygen is still electronegative and hydrogen is electropositive. Now what is going to be happening, there is an attraction point. Now this is quite interesting, there is a covalent bonding between H and O, H and O, no doubt H is H and O, there is covalent bonding is to be there. But what happens as far as this is O, that is oxygen, which is to be as an electronegative, which going to be attracts to the another H from the another segment, and here it going to be the case where the dipoling or the interaction is to be there in between this oxygen and the H of another H2O, and that is how this is what the case where it is to be as an interaction of the particular in between these dipoles are nothing but to be called hydrogen bonds are to be there. मीन्स हा जो ऑक्सिजन आहे एका सेगमेंटचा म्हणजे एका H2O चा कंप्लीटवाला, तो दुसऱ्या ड्रॉपच्या H2O च्या H ला अट्रॅक्ट करतो. का बरं? कारण ऑक्सिजन हा इलेक्ट्रोनिगेटिव्ह आहे आणि हायड्रोजन हा इलेक्ट्रोपॉझिटिव्ह आहे. तुम्ही तर इथं तर ऑलरेडी हा बॉन्डिंग फॉर्म केली, इथं जरी बॉन्डिंग फॉर्म केली तरी हा इलेक्ट्रोनिगेटिव्ह स्ट्रॉंग आहेच आहे, कारण ह्याच्याजवळ जास्त इलेक्ट्रॉन्स आहेत. आणि हा इलेक्ट्रोपॉझिटिव्ह दुसऱ्यामधला आहेच आहे, कारण याच्याजवळ एकच इलेक्ट्रॉन होता आणि म्हणून हा इलेक्ट्रोपॉझिटिव्ह आहे, हा इलेक्ट्रोनिगेटिव्ह आहे. मग ह्याच्याजवळची स्ट्रेंथ आणखीन जास्त आहे, ते त्याला काय करते, इतर एचला अट्रॅक्ट करते दुसऱ्या मॉलिक्युल सेगमेंटमधल्या, आणि त्याच्यामुळे जे काही डायपोल इंटरॅक्शन फॉर्म होते त्याला आपण हायड्रोजन बॉन्ड पर्टिक्युलरली म्हणतो. आणि जर समजा याच्यामध्ये हायड्रोजनच्या ऐवजी दुसरा एखादा बिसाइड्स दॅट एखादा मॉलिक्यूल असेल तर त्यावेळेस त्याला आपण डायपोल बॉन्ड्स म्हणतो, कारण इट इज नथिंग बट टू बी इंटरॅक्शन बिटवीन द डायपोल्स आर टू बी देअर, and the such type of the bonds are nothing but to be called your hydrogen bonds are to be there. आणि म्हणून जेव्हा आपण म्हणतो किंवा कोव्हॅलंट बॉन्ड जर स्ट्रॉंग आहे तर मग पाणी वेगळं का होतंय, इट इज ड्यू टू दॅट दी H2O1 इज गोइंग टू बी ब्रेकिंग, इट इज नॉट ब्रेकिंग H फ्रॉम O. जेव्हा आपण पाणी म्हणजे एक ड्रॉप बाजूला करतो त्यावेळेस इट इज नॉट ब्रेकिंग दिस covalent bond, it breaks this hydrogen bond. Breaking of this hydrogen bond is very easy, but breaking is of this particular H2O covalent bond, it is not possible easily. मग तुम्ही पाणी जर वेगळं करता तेव्हा तुम्ही हायड्रोजन बॉन्ड ब्रेक करत असता, इट इज व्हेरी इझी टू ब्रेक, बट यू आर नॉट ब्रेकिंग दिस H with O, that is covalent bond you are not breaking, and that is what the case where you can see the differences are to be there. So this is where the dipole interaction is shown here in this case. Here also it is going to be formed, and it is nothing but to be there hydrogen bonds are to be there. Now as far as these hydrogen bonds are going to be concerned, these are not too much strong, as no doubt these are excuse me, these are stronger than the van der Waals bond, but not as good as your ionic bond and the covalent bonds are to be there. That's why hydrogen bonds basically stronger than the dipole bonds are to be there. No doubt melting and the boiling point is higher, and the hydrogen bond plays an important role in the formation of the ice. No doubt this is the one of the important part for the as far as ice making and the water. This particular bond are very much playing important role, because the temperature is going down, and in that case the whatever be the formation of the ice or the water is to be there. As far as the binding energy of the water is to be there, it is nearly 0.5 electron volt is to be there. And as far as the direction, these are bonds are directional in nature are to be there, and in absence of the hydrogen bonds water have the boiling point nearly it is minus 80, and the viscosity is 0.01 is to be there. And this is what the case where the hydrogen bonds are going to be working in this case. So as far as these bonds are very much easier one, and we will finishing this bondings basically with this part. As far as the strongest bonds are the ionic bonds, which are having the very strong binding and the melting point is to be there, and the energy release is max in that case. That's why the ionic bonds are stronger, covalent bonds are second one, van der Waals bonds are little bit weaker and most weakest bond, and the hydrogen bonds are in between them is to be there. So we will cover this all the bondings in the solids. The next part is X-ray diffraction, and that we will see tomorrow. Still be at home and be safe. Thank you.